So in this video, we're going to look at an example where it doesn't at first appear to match, where an integral doesn't appear to match any of the patterns in the table of integrals, but if we make an appropriate substitution, we can get a match to happen. So here I have the integral of x over 1 plus e to the x squared dx. And if you look in the table of integrals that I provided you, this is the only thing that even comes close to matching that pattern. So on its face, this looks like we can't use this identity to manipulate this into an integrable form. However, what we want to notice is because the derivative of the exponent x squared is here in the numerator, it only differs by a constant. If we make an appropriate u-substitution, we can get a form that will allow us to do the integration. So if we let u equal x squared, the exponent on e, then du dx is equal to 2x. Multiplying both sides by dx, we get du is twice x dx, and then multiplying both sides by a half, we see that the x dx could be replaced with a 1/2 du. So if we go ahead and do that, we pull the 1/2, which is a constant, out in front of the integral, and we're going to be left with the integral of 1 over 1 plus e to the u du. And this matches exactly the pattern that we see here. Remember, the x is just arbitrary. This could be 1 over 1 plus e to the t dt equals t minus the natural log of 1 plus e to the t. So the x is just it's just a variable name. So we want to be flexible and recognize that this pattern is exactly this pattern, which means we can apply the pattern or the identity. We can say this integral is the same as this integral, so we replace this with, instead of x, we'll be replacing it with u, and it'll be minus the natural log of 1 plus e to the u, close it off, plus a constant of integration equals a half times, and we did a substitution, so we're going to replace the u's with the x squareds to put it back into the original coordinate system, all plus a constant of integration. So the key here is that in many instances there's going to need to be a substitution that happens in order to get things to look the way that they do in the integral table.